Hello and welcome to today's webinar. My name is Jake Pineda. I'm a marketing coordinator at the Council of Supply Chain Management Professionals. I'm very excited about our webinar today and hope you all enjoy this. We do have a large amount of attendees and a lot are still flowing in. So while we give them a few extra seconds here, I'd like to touch on a little bit of housekeeping for the webinar. All attendees are on listen-only mode, but we would love for you to submit any questions you have using the questions box in the GoToWebinar control panel. Really, again, appreciate everyone who's able to make it today. And with that, I will go ahead and pass this over to our presenters from Sofyan, Dan Gilmore and Dinesh Dangre.
Hey, thanks so much, Jake. Appreciate everybody. This is Dan Gilmore from Sofyan. I'll more formally introduce myself in a second, but thank you for coming to this webinar on warehouse execution systems and what we think is becoming, and already is to an extent, the smart distribution center. So this seems to be a hot topic. I say that both because of the conversations I and Dinesh are having in the marketplace and conferences and whatnot, and also just because the big registration for this event kind of indicates a lot of interest in the topic. So got a lot of ground to cover. We're going to go through it fairly promptly. That'll both help us get done. I'm hoping well short of the full hour that we're allotted here, and give us some time to take some of your questions. So with that, going to just kind of get going with the introduction. If I can get my slide to move. Okay, oops. A little trouble advancing the slide here. Bear with me. Well, that's unusual. Sorry, folks, not a very auspicious start here. I don't know why my slides are not advancing. Just bear with me 1 second, and we should be good. Dinesh, maybe does it make sense? I'm not sure what's happening. Does it make sense maybe for you to, hold on, I'm sorry, folks. Well, there we go. All right, something worked. Okay, here we go. So here's our speaker today. I'm Chief Marketing Officer at the Sofyan. We're a supply chain software company. And you may also know me from the First Thoughts columns. I've been writing a Supply Chain Digest now for almost 20 years coming up. So I'm sure some of you have seen that. And my partner in crime here is Dinesh Dangre. He's VP of Strategy at Sofyan. Very smart, very technical guy. He'll lead a lot of the technical conversation here. So just so you know who the heck Sofyan is before we start talking, we're a supply chain software company of a wide product suite kind of focused around warehouse management, all of these components on a one single common platform, Lego-like plug-and-play approach. More recently, this notion of the warehouse execution system, and that's the core of what we're going to talk about today, but it's really an extension of the WMS that can be deployed separately, and then this newer thing called distributed order management in terms of identifying the right place to source an order from at least possible cost and meet customer service requirements. And so just give you a sense, got a broad suite of products, but we're focused today on WMS and WES. Just some example customers. I'm not going to go through these in any detail, but a good mix of some very large companies here, as well as a lot of mid-sized companies, especially in the third-party logistics or logistics service provider market that we serve, and across a wide variety of industries. Got about almost all of them covered. So that's just to give you some idea who you're talking here today and some of the background that we bring to this conversation. I will note that Dinesh and I co-authored a CSCMP Hot Topics report, I guess, whatever you call it, that was published by CSCMP last June. It mirrors a lot of what we're going to talk about today. We're going to talk about some other things as well, but this report may be a nice summary for you. We'll try to make it available to all registrants after the event, but you can also go out to cscmp.org and go under the research or the content or something section. You'll find the Hot Topics menu, and you can download, just search for WMS, and that's how I found it. And you can download that for free. You have to go through a shopping cart, but the price is $0. And you can get that quickly. So this will be a nice companion to the materials that we're going to present today if you want to go out and get some additional information. So here's kind of the current scenario here. WMS is a very good. I first implemented my first WMS I implemented was in the late 1990s at Totes Isotoner. So I've been around this business a long time. Dinesh, significant experience. But the question is how smart are they? So they're very efficient and there's a lot of business logic. But in the way we think about smart today, maybe not so much. And Dinesh, I don't know, any initial thoughts on this? Or the WMSs we know, even from tier one providers, are they really smart?
Yeah, no, I think, when you talk about smart, it is one thing about, it really lends itself to learning in the most part. So the challenge with WMS, I think, is they have over time, looked at specific process threads and optimized and done a fabulous job in terms of the, evolution of WMS products itself. But what fundamentally WMS, I think, misses is the feedback loop, the learning that comes out of, reacting and recognizing signals in a feedback pattern. So it is always a progressive forward mode saying, do this, hand off, so to speak. But there is really no feedback. There is visibility, but not really feedback to actually initiate actions or reorchestrate stuff.
No, very good. Well said, Bill. Thank you. So, part of the challenge for all of us out there and you in the audience is, as well is, we got some overlapping options here, and I'm going to go through a little history on this. We got WMS that's been around since 1975, first a real-time WMS implemented all the way back in the mid-1970s, so 45 years worth or so, give or take. We've got this newer thing called WES, Warehouse Execution System, and then we've got Warehouse Control System, which more has to do with moving the conveyors and all of those sorts of things. So it just adds, but there's some overlap. All these things have some overlap to them. If I was to draw a kind of more tight circles, there'd be overlap between all three of those in certain places, certainly between WES and WMS or WMS and WCS. And then, on top of that, we've got this more recent phenomenon of, artificial intelligence and machine learning, as Dinesh was talking about there. So just a lot of different, pieces in movement, parts in movement here. But I've done this before at various conferences, so some of you may have seen it. But I just kind of want to, give you some thoughts from me on how we got here. So I fundamentally believe, and I believed that long before I went to Softian, that when you have WMS and WCS, which is the thing that controls the movement of the automation, if you will, getting something from point A to point B, that the WMS should have all of the smarts and the business logic, and that the WCS should just be the executor of what the WMS has decided to do. The WMS decides this carton should go here. It sends that message to the warehouse control system, and whatever technology is being used, sorters, conveyor, shuttle systems, whatever, the automation system, the WCS, is just going to execute that command. And why do I say that? Well, because if you put smarts or logic in the WCS as well, it just adds another layer of complexity. And often when you go to make a change, rather than just making the change in the WMS and letting it flow through to the WCS for execution, rather you have to make changes in both places because there's logic built into both. So that's really what I think is the right way to go. And most of the consultants and others I know agree with me. But it doesn't always work that way. And sometimes there is, in fact, WCS intelligence and also, of course, more intelligence in the WMS, but there's some smarts in the WCS. Why does that happen? Well, it happens for a number of different reasons. First off, sometimes it's an automation system going into a facility that has an older WMS, and the WMS just lacks the capabilities to well support the automation system, and so the WCS gets kind of bulked up in order to handle the WMS shortcomings. Sometimes, frankly, some of the large materials handling vendors are kind of in control of the customer. They're kind of running the project and the deal, and they want to add as much value as they can, and they've got their own WCSs, and sometimes they just build some of that, smarts into the WCS because they can kind of, call the shots there. And then maybe a small dirty little secret of the industry is that sometimes the WMS and the WCS vendors kind of get together and kind of divide up the pie, if you will, in terms of who's going to do what. And sometimes the path of least resistance is just to let the WES vendor do some of the smarts. But I think in the end, that's not a very good decision. But it does happen. It just shows the kind of complexity that's going on out here. And then, more recently, we've got this phenomenon of WES. And WES, as it was originally envisioned, kind of wants to be the smart, making a lot of decisions around order picking and fulfillment, kind of relegating the WMS to more of an inbound function and reserve inventory management and maybe some of the checkout side and truck loading. But a lot of the smarts really with the WMS and WCS or WES and the WCS, back to its execution mode. Why did this happen? Well, it's because really two companies, I think, maybe a third, I'm not sure, but a couple of companies kind of perceived that there were some shortcomings in the WMS. And the biggest shortcoming there was the lack of attention really to MHE, materials handling equipment utilization, that there was opportunities to get better performance or reduce the amount of equipment that's needed from taking more control over that utilization function through some smarts. In general, I'm going to say that observation was probably right. I think there were some WMSs out there that were more concerned with equipment utilization than others were. But that's what kind of spawned the industry. It kind of sputtered along for a number of years, but in the last 3 years, give or take, there's been a tremendous interest in WES, particularly as facilities automate to reduce costs and meet the needs of e-fulfillment, huge driver of systems in the industry, and the need to coordinate activities across a number of different systems in the warehouse and do so more efficiently, and that facilitate the smooth flow of goods throughout the entire shift or day of work has really brought the WES to the forefront of the industry. So just trying to clarify a little bit, this is from the analysts at Gartner. This is something they put out, I think, 2019. It just kind of lays out the WCS, WES, and WMS background landscape and who controls what. I'm not going to go much into the WMS. It's receiving, put away, pick, pack, ship, all the stuff that we've known for, like I say, more than 4 decades. On the warehouse control system, again, it says it's a middleware that sits between the WMS and the PLCs of the control systems of the conveyor. And really, again, it should just, be associated with the executing instructions of where products should go from the WMS or increasingly from the WES. Gartner calls it an emerging hybrid, blends capabilities from both WMS and WCS. So it's partially true. And builds on, WES's real-time insight into what's happening in an automated warehouse. And again, that's largely true. But we think there's some opportunities here to think about it a little more broadly. WES is not only for heavily automated DCs. We have several examples within Softeon of WES execution in a more manual or light automation environment. And you think about it, a case pick area with a given number of workers has inputs and outputs just like a piece of equipment does. And it has expected volumes and throughput, like I say. And so you can mirror that logic and thinking for a group of human pickers in a case pick module, the same way you can a machine some other part of the facility. The one interesting dynamic is that with a more non-automated or manual environment, you actually have more flexibility in terms of what that throughput is. I can add or take away resources to impact how I want that system to be executing, whereas equipment, largely fixed capacity, it can do so many cartons an hour or whatever the metric is that you're looking at, and so you don't have quite the same flexibility. And I just add to what Gartner said there, that there's really some advanced fulfillment and what's called optimization and orchestration. We're going to go into some of that today that, takes WES maybe a little bit beyond what the definition we saw there on the screen was. So just one more piece from Gartner there, because we think this is some good thinking. So this is Dwight Klapik, again, I believe in 2019, last year or so. And he talks about that there's really just not, WMSs historically have been more reactive to what's in front of them, not allow opportunity to plan in a constraint-based way, the way you often do in the manufacturing there. You see down at the bottom of the screen, this is no longer good enough. The smart warehouse is the future platform that addresses that reality. And the graphic on the right depicts Gartner's view of what that is. And notably, you'll see below WMS there in the center, you're going to see warehouse execution systems circling the bottom half there as a fundamental component of what Gartner views the smart warehouse. So kind of what do we think about that? We think the WES is an extension of the WMS. It can be deployed certainly together and work hand in hand. It can also be deployed in standalone mode on, whatever WMS happens to be in place. So when I say extension of WMS, that implies a single vendor providing WMS and WES. The deployed standalone means you can take WES capabilities and add them, say, to a legacy WMS or some other system to kind of rejuvenate it in terms of throughput and technology or throughput and results, but actually leave some of the things in place in terms of inventory control, ERP transactions, and things along those lines. So this is a bit of a mouthful, but it provides new levels of visibility, control, orchestration, how does the work flow across the floor, and optimization and picking and related processes, things like replenishment, of course, and optimizing all the flows of material handling flows, manual or automated, beyond what has been available today, even in advanced warehouse management systems. So I said a second ago, work for the automated, non-automated, and hybrid, which I mean moderately automated DCs. But if you are automated, no one's completely automated. There's always manual elements of the process. But if it's largely automated, how do you manage and coordinate the flow of goods across all those systems so they're not individual silos, but are viewed as a single system and generating the flow and the throughput that the system is capable of? And it really provides the path down there at the bottom to deliver what is increasingly being called the autonomous WMS, that is less reliant on human decision-making and automating a lot more of the flow of work and tasks out onto the distribution center floor. I just note that UPS, which is a customer of Softeon, in a press release last week of April 2020, talked about how they were rolling out their new Smart Warehouse of the Future initiative, and the technology platform they were using to do that is Softeon WMS and WES. So I just bring this up to show that this isn't just some idle concept or whatever. Things are really happening out there in terms of the smart warehouse and software technology. WMS, WES, of course, a critical part of that. So this is kind of interesting here. If you look at the things that a WMS historically manages, things like orders, things like inventory, things like people, things like work, things like automation, right? So you've had that in place, but with, as we said at the beginning of the broadcast, a limited amount of really smarts and self-learning. WES provides this layer of automated decision-making across those things, taking them up to another level of achievement and performance. And it does so by a couple of things down the bottom left: granular visibility to processes and what's happening in different work areas. We'll talk about that in a second. Orchestration optimization, I've mentioned that a couple of times already. Automating that flow of work in terms of priorities, capacities, workload, available resources, and a lot more different variables. And it's not always necessary, but it certainly opens up the opportunity for so-called waveless picking. And then it's going to interface on the far right there with a number of different warehouse control systems. So, Dinesh, any kind of thoughts on this here? I mean, really, we're talking about the same things: orders, inventory, people, work, etc. But we're just doing it with a new level of smarts.
Yeah, I think the main call out, or the thing that stands out with this is if you look at historically like a WMS or a labor management system, they all tended to address the needs of a specific scope of work or functional area or logical context. But if you notice here, WES fundamentally is set up to facilitate orchestration and collaboration. So it is not set up for orders, it's not set up for inventory, it's not set up for people. It is set up for everything that needs to work together, everything that needs to collaborate. So conceptually, WES is a very different paradigm than functional products that were set up to do certain specific things. This is genuinely set up to ensure collaboration across a series of things. And now the other individual components to this could be a single system, could be different systems, but WES sitting on top is really orchestrating all of this stuff. So it's a very different mindset to how you think about this product and how it actually can be deployed in a certain landscape.
Very good. Very well said again. So I'm not going to go through all of this, but what does these smarts do for you? Well, this is just, and we'll make these slides available to you, of course, but just showing you some different things here across order processing, inventory management, capacity management, resource management, et cetera. We'll have some more on this later, but just, there's a smart way to do this now, and ones that are less smart and hence are less efficient, more costly, more trouble meeting customer service requirements, whatever. And you see some different things there, on the, inventory and layout management, some of the wave tails. We're going to talk about that more in general, where it takes 20% of the time to get 80% of the wave done and 80% of the time to get the last 20% done. Very common type scenario here. So, obviously the goal is to get to the done smartly capabilities, such as you see here in this little diagram. So I talked about that granular visibility. This is just an example of a kind of dashboard that shows, a wide variety of statistics around open orders and carts and picking status, et cetera, pending case pick lines, et cetera. The key thing here is that, of course, you should be able, this is just like a management dashboard, right, to manage the operation at a finer granularity than typically is seen in WMSs, okay? Of course, you should be able to drill down into this from a management perspective and see all the detail behind each one of these. But then that's the important point, right, is that this is not just to help supervisors or managers with this kind of dashboard information to manage whatever area that they're operating in at a point in time. This same data is what the WES is using to drive the optimization and orchestration.
Yeah, no, absolutely. And that is fundamentally the context of saying, what smarts is WMS missing? I mean, they have the data. They could pull, real-time visibility to certain, elements of process, but acting on them is what is missing in a WMS, and WES is what is acting on this information. And we'll address along the way in terms of what that means in terms of dynamically adapting, dynamically learning, and readjusting, reprioritizing, whatever the context is. So this fundamental context of information, which is a feedback or constraint, real-time constraints that are popping up and on the floor, is what WS leverages in order to optimize and be smart about how work is being executed within the four walls.
Yeah. So if you think about that, there's, this is the same information is being used in a presentation type style to help manual decision making and solving throughput issues or bottlenecks or whatever it happens to be and making sure you're on track. But that same information from a systemic way is feeding the WMS so it can make automated decisions about what work needs to be done where and how it's coordinated. So this can get very fancy. This is just another set of dashboards you see here. I mean, this is set up. I mean, it's just made up data. The data is kind of meaningless, but just you see are different, different style of dashboard that's looking across different pick areas or processing areas across the distribution center and giving a dynamic real-time view of how the throughput is going and how is it matching up versus expectations. I'm thinking I'm going to get 200 an hour done and I'm only getting 150 an hour done. What's the problem and how do I react to that? So this is, again, where all of this is headed in terms of information, feedback, and communication. So, here's just another example. One of the things that's changing, and if you read some of the Gartner stuff, you'll see this, is, manufacturing has been used to, kind of a time-phased, constraint-driven planning paradigm for decades, but that really hasn't entered the WMS market. You notice here, this is just, again, kind of made up data, but it's showing a curve here showing what the demand is. This is across, it could be at any level of the distribution center. This is for the case picker, this made up example, but you see here it's looking by hour, 1,300 hours, 1,400 hours, 1,500 hours, et cetera, what the projected load is going to be versus the demand load versus the capacity. And this is where, because you don't often know what that load is going to be at the beginning of the day or the beginning of a shift, this is where simulation kind of comes into play. And Dinesh, you might comment on how simulation is used to provide this kind of insight.
Yeah, and I think so. If you think about looking at demand and future state and looking at optimizing, and really you're looking and identifying areas of constraints. Primarily driven from demand, but in a lot of cases it's also by capacity. So when you look at, historically simulation has been part of a design concept. So when you look facility design, when you set up a new process, there is some concept of theoretical simulation that you do and identify and define a certain behavior for the solution. But that's a point in time. So, but what is needed is the ability to rerun the same patterns, to rerun the same things in a more dynamic, more real-time manner. So when you look at a WS and we talk about, whether it is a predictive way of looking at demand, whether it is a statistical model of looking at demand, machine learning and so forth, then what WS is really doing is looking at, in more granularity and more real time, looking at information that is coming in, identifying potential for information likely to happen, constraints that are likely to come up, and then readjusting and reorchestrating stuff. So while simulation can be a one-off event that can be set up in terms of a certain metric or objective, inherently WS is looking at the same concept when we're looking ahead and identifying constraints, identifying things that need to be readjusted upfront based on a future state behavior is what WS is doing. So it's doing a lot more simulation as part of its regular activity as opposed to a one-off.
So just following up on what Dinesh said there, so at the beginning of the day today, it's not like hardly anyone today gets the mass dump of orders for the day at midnight or 4 o'clock in the morning or whatever your pattern is, right? Orders are just flowing in, and so what this allows you to do is to predict what the capacity and capabilities are going to be based on what history or order patterns or whatever that happens to be. Because at the beginning of the day, you only know 20% of the work or 30% of the work, whatever it happens to be. As the day goes on, more and more becomes known, less and less needs to be forecast and simulated. So just some additional thoughts.
That's true. That is true. So, a big part of that also is, for example, you could pull in information from, forecasts outside of external systems, and you can plan for the day, you can plan for stuff. But that's one stream of a demand pattern coming in from externally sourced, whatever the trend is, whether there's a campaign going on and so on and so forth. But there is also historical precedence for how a floor or an operation is actually performing for a certain load. So it's a combination of trying to pull that information together. And this is where, we could call it machine learning. Really what it is taking a lot more factors into consideration across and computing and making decisions much, much faster than a human can do. When you have to consider 10 different factors to make a decision, can a human do it? Absolutely. But it takes a bit longer. At some point, you're going to weight it differently. But with the machine or with systems, technology, you have the ability to pull in all of those factors a lot more quicker, a lot more impulsively, instinctively, and then make decisions much quicker than a human can do.
Very good. So, talking about smarts here, this is just a chart, and again, I'll send these out to you as slides after the broadcast, but just shows the kind of questions that we can now answer and optimize within WES construct here. What's the best set of orders to release to the floor right now? How many orders do we release? What's the batch look like based on current capacity? How do we consolidate those picks within that batch in the most logical way? Kind of in the third one over there, what are the optimal resources we need to execute against what we now know is going to likely be the volumes ahead based on that simulation that we just showed you a second ago? Where do I put different people in different areas, et cetera, et cetera? So these are just, the kind of questions that the WES, in combination with the WS, is now able to answer and automatically execute. And one of the key differences between WES and what we've historically thought about in terms of WMS is that the WES is what we call always on. And Dinesh, maybe I'll let you take a stab at that. What is that, when we say always on, what does that really mean?
Well, I mean, for a little bit of levity here. So, it's more about, what it means is it's always receptive to feedback, and it's never uncomfortable with feedback. So when you look at, when we looked at the dashboards and stuff, yes, there are planners, there are people who can sit and monitor, look at the stuff, make choices, reassign resources, balance workload. They could do all that stuff. But as with anything else, the amount of time that a person can spend in terms of looking for feedback and accepting feedback is constrained. I mean, granted, people are only so much feedback we can take. But with the WS type product, when we say always on, it means that it is always looking for feedback, always seeking feedback, always observing feedback, and then making choices on there. So it's continuously doing the stuff without any limitation, without any feeling of, well, I've done this, I'll do it in the next 5 minutes or the next hour or so because I know this is what it's going to take. So it doesn't have any of those typical constraints that would you anticipate with human intervention. So that's what an always on means. It from a WS perspective, it is consistently and continuously looking for feedback and then continuously making choices, they're pushing stuff out for people to execute.
Yeah, I like to kind of think of it that the WES is kind of always listening or always observing all these things that are happening in the warehouse, and it triggers those changes as that happens. It triggers automated decision making rather than as Dinesh, as you well said there, waiting for a human being to look at all this data and decide what to do next.
Correct. That's right.
A little bit slow with stuff here. Okay, here we go. Sorry. In terms of that automated, my screen's going to slow up here again. I'm sorry, bear with me a second. There we go. So we've been talking quite a bit about, around this notion of automated, order and work release, and how does that happen? Well, there's, a dynamic rules engine. I'm going to let Dinesh talk about that in a second, that is looking out there across, the entire pool of orders and different tasks that are out there. It's going to consider things like order attributes, the priority, the ship date, the customer, et cetera. What is my labor capacity, and the rate I expect in each of those different areas? What equipment do I have? What limitations and capacities do they have? How is the order prioritized and then reprioritized if it isn't executed in a timely fashion? Balancing that workload across different areas. I talked about that earlier in the broadcast. And the best channel, all these different processing areas we had. Do I have multiple ways? Maybe there's one way that I go through an auto store or something like that. But if I reach capacity there, I've got a cart pick option that's going to give me another path there. And so the WES, in combination with the WMS, is going to factor in all of these things and to continuously flow a set of work out into the floor. We talked about that waveless concept before. It doesn't have to be waveless. It works quite well in a wave-based environment as well. Matter of fact, we're seeing a lot of waveless in the e-com area and wave-based in the B2B area in a single facility. But, Dinesh, I guess, and it's kind of a little bit, techie, but kind of key to this is this notion of a dynamic rules engine. Can you give us a layman's, explanation of what that really means?
Yeah, I mean, the The dynamic part, I mean, the rule part is pretty clear, saying if, this happens or if this is the case, go do this. I mean, the dynamic part comes from, of course, the feedback and incorporating that feedback. And that feedback can be one of many things. It could be a change in demand. It can be a new constraint. It could be reduced capacity and so forth. So being able to adopt and accommodate that feedback into a process definition that is set up as a rule dynamically is what the dynamic rule is. And as a simple example, if you could say, well, if you had robots and you had manual carts for both potentially set up for picking products. As a general thumb rule, you're looking for cart picks to be much higher density because the cost of people traveling is significantly higher, so you don't want them to be traveling across. Whereas you could potentially say a robot can go across multiple zones. So you could have it organized that way as a rule, saying this is my preference for how you want to do that. But as the day goes, as the demand comes in, if things change, the reality is that you may not always be in a position to create the same density to do a manual cart pick. Then does it make sense for a robot to be sent to a manual cart pick area, or should a robot be also incorporating certain profiles that typically would have been within a zone for a manual cart pick? So this dynamic decision that is being made within the context of the original rule. The rule said do this and this in certain profiles, but dynamically you're saying, well, I'm going to make that accommodation and not be stuck with the same concept of how to execute, is what that dynamic rule is. So it is a notion of an input that is set up in terms of how you want to orchestrate certain elements of the process, but then letting the system determine the best of those choices based on ground conditions at that point in time and in real time.
Yeah, and that's the dynamic part, right? So we can have a kind of a fixed path set of rules that kind of dictate what's going to happen, but when you combine the dynamic rules with that always on sort of concept there, that's a sort of real time agility that WES is capable of providing. So that's what I kind of talked about, this dynamic aware pick release process where the system is considering a lot of different factors here in terms of the condition and event monitoring in terms of what's actually happening there, and then what are all the variables we just talked about there. And at the end of the day, it's how do I ensure that the stuff that needs to get on the FedEx truck that's leaving at 4:30 actually makes it there plenty well in time and consistently does that, versus the kind of mini chaos and panic mode as that cutoff time is approaching. Challenges in meeting that on a consistent basis. So this is, kind of a busy eye chart, but, Dinesh, you might talk a little bit about what's going on here. You already spoke to it a second ago, really, but, what's kind of going on here in terms of, optimally releasing that work to the floor.
Well, I think it's two parts. One part is the actual execution part. So the main call out here is it's just not specific to, as you can notice, it's not specific to a pick strategy. It is also tied to what happens downstream, whether it's a pack station, whether it's shipping, whether there is a replenishment or, any other automation that's involved with each of these things. So this is just a representative mod. So the first piece is, it is looking at feedback and addressing feedback across all of these elements, entire process thread all the way out. It is monitoring and determining what is the best reorchestration that needs to be done for a pool of work. But the second piece that it is also doing, and this is where, when we talk about smart or a systemic incorporation of feedback, is the fact that system will also determine and package a slightly buffer, if you will, for a future load. So it is not just saying, okay, I have these 20 orders, these are the 20 pickers that I have, I'm sending them out. It is also anticipating the time it is going to take for them and preparing work for when that picker finishes to autonomously release. So it really is a continuous flow that is happening. So the condition and event monitor is not just making sure that what you anticipated to work is working, or removing stuff if the constraints pop up, but it is also planning ahead so that there is this continuous autonomous flow of things where people don't have to be involved with making choices and decisions.
Yeah, and I just know, sometimes, of course, there's dependencies. We show, here made up kind of example, but we got a footwall in this diagram there, and that could be dependent on what's happening in the case in each picking area. So the footwall could be starved or overwhelmed, or happily right down the middle, depending on what's happening at the upstream processes. And so that's something that the WS also needs to consider, especially if there are multiple paths to picking and shipping an order available in the facility. So here's just a simple example, and Dinesh kind of harked to it a second ago, but we're seeing a lot of interest in footwalls out there. We've implemented a number of them at different customers. But let's take a simple example. The whole key to footwall systems is the quick turnaround of those slots or those cubby holes, whatever term you want to use there. So let's say we have an order, an e-commerce order. It doesn't have to be e-commerce, it could be auto parts order, with 3 lines on it, and 2 are coming from the lower level in a high-speed carton flow rack environment, and 1 is coming up from a mezzanine further away with static shelving. And I'm just making this up there, but this is the kind of feedback we're getting. Let's say the mezzanine picks take 25% longer to pick and transport, whether that's manual transport or automated conveyor transport, to the put walls. Well, what happens? Well, what happens is that if you release all of those lines at the same time, the orders from the carton flow rack are going to get there much faster than the orders for from the mezzanine. And now you've got perhaps a cubby hole that's held up for 30, 40, even longer, sometimes minutes, waiting to get turned. And that just takes away the whole effectiveness of the put wall construct. So what's the alternative? Well, the WMS can be aware of that. It can release those mezzanine picks. In effect, it wouldn't be exactly this, but I'll say it anyways. In effect, 25% earlier than the carton flow rack picks, so that all 3 line items arrive at the put wall at about the same time. And then, as we've been kind of saying, you can use machine learning to, get better at, the system gets better at predicting that total cycle time from the 2 different areas, and continues to tweak the release timing based on that learning that it's made over time. So just a very simple example, but a very practical one that we're seeing a lot of different places, and just to illustrate the concept of that smart decision making. A lot of different facilities have many different processes, whether those are manual or automated. We just called out some here that are typically constraint points. But the point really is that all of these operations have different clock speeds, right? And what we're seeing is a lot of kind of contemplated flow of goods out of the warehouse, number of warehouses, even heavily automated ones. And a lot of times that's because the clock speeds of these different processes within the facility are not being adequately considered. And so you get big peaks and valley, and second, you get, a lot of wait time at different areas, or they're overwhelmed in volume and overly congested. So again, this is, what WES can do to consider all those things in a time-phased way to keep that continuous flow of goods, as Dinesh was talking about just a second ago. I'm not going to spend much time on this, but kind of wrapping up the main WES part, we also see that there's going to be an opportunity for users in a smart WMS+WES environment to do a lot more interaction with the system in terms of voice. So rather than just doing basic voice picking or whatever application you're doing, becomes more of a Siri type environment where people are allowed to ask questions like, I need to make, take great tasks, like I need a replenishment for this location, or where are we on this wave, or whatever it happens to be. We think that this voice interface into the system, what Gartner and others call conversational voice, is certainly going to be an important part over time of the smart WMS of the future. So, we think that it can deliver some real value here. We're still, I'd say, we got a number of implementations, but they're still in somewhat early phases. But, seeing reduction of full-time equivalents in the, 12, 15 to 20% way, big improvements in cycle time, equipment utilization, throughput 10, 15%, et cetera. There's some numbers in that UPS press release that I presented at the beginning of the show of experience that they had with one customer. So, the opportunities are very real. And, one of the things, if you do have, whether you have an automated environment or you don't have an automated environment, the, peaks and valleys that we're seeing here, this is fairly common. And this, this problem was what, WES was originally kind of designed to, to do. You have big spikes in volume on this, who hasn't walked into a DC and seen a sorter? One moment it's packed with cartons, the next moment it's starved, waiting for the next set of work to start coming in. So the promise is that we can move from this, highly variable sort of throughput environment to one that's a lot more smooth and a lot more consistent. And that can either allow you to get more throughput out of the equipment or the systems and the people that you have, or if you're going into this in more of a greenfield environment, may allow you to actually reduce the amount of equipment you need because that throughput is much more consistent. At the end of the day, much more higher volumes in total because of that level loading of the work. So just kind of, summing it up here, I think we really have entered into a new era for the warehouse software market. It's a combination of WMS, but especially now as an extension of WMS or as a standalone solution, this WES. It's going to deliver the optimization factory and all those variables we've been talking about throughout this broadcast. The dynamic orchestration, that's really the key of how do I manage in a smart way that flow of work across a complex distribution center. Part of the way I do that is being capacity and constraint aware in terms of making decisions and automating the release of work based on many variables. This is very different, and that always on process that we talked about. And I'll just say, this is not a vision. These capabilities really are available today. There's more to come, but it is really kind of delivering, as we've said, this kind of pull-based, what you might call flow distribution. So, Dinesh, anything you would add to the summary here?
I think just a couple of closing thoughts. I think WS, WMS today are discrete markets, discrete products, and I think as WMS has evolved with extended features, whether it's pieces of transportation, pieces of labor, slotting, so on and so forth. I think WES, rather than an independent work thread, I think people should really look at WMS and WES as really more holistically as a singular solution in order to gain not just the core functions that typical receipt, putaways and type of stuff that will always stay in WMS, but also looking at something that fundamentally is structured for orchestration across different things. So the use cases can be very different when you start putting these things together in terms of ROIs and stuff. So with just a traditional WMS, you might be saying, well, I want to reduce labor, I want to find different big strategies to reduce my cost to serve with very specific discrete behavioral patterns. But once you start putting WS in there, it is not just looking at the same concept, but it is also looking at, can I distribute? Can I move load around during the day so I can reduce overtime, I can reduce temp labor outside of the discrete context, but based on a day-to-day. So if you look at overtime, it is not something that you plan ahead of time. It is just something that if it is needed, then you incorporate and you pay the cost for an overtime. But with something like a WS, if you're able to in real time distribute, manage, smoothen the load, irrespective of whether it's automated or a non-automated environment, then you're creating these use cases for savings and reduction of cost to serve that discrete processes typically cannot give. So I believe that WES can always be an add-on, but I think if you're looking at WMS or replacing WMS or implementing new technology, then looking at more holistically all of this together as opposed to a specific siloed WMS type behavior might be more appropriate way to go, especially given the newer innovation that's coming with wearable technology. So when we talk about task release, typically there is a pull. Somebody logs in and says, what can I do next? What can I do next? That's a pull type system. But there's newer wearable technologies coming through. So when you look at optimal task management, optimal task releasing, the right set of things, you can move very quickly into a push type mode where tasks just show up for people to do. They're not looking for what do I do next. It's just pushing the right set of things to the people, and they're just blindly doing it. So it takes away training. You can have new labor come on and just execute stuff. So there is a lot of implicit, intangible benefits that you see. So I think there is a lot more innovation, a lot more opportunity to go down this smart warehouse path. But I think the industry is already there, and a lot of products. Of course, we have seen with our own client base benefits and the journey down the smart warehouse and autonomous warehouse already having started to a fair degree.
Very good. Okay, well, I got done largely on time, 45 minutes or so, which is what I was hoping to accomplish there. We do have a little bit of time for questions. There have been a handful that have come in during the chat type window. So I'm just going to kind of take some of those. Actually, Dinesh, we got a couple of questions relative to how does a WES implementation differ from a WMS implementation? I know you're involved in one very big project right now, so I'm sure this is sometimes on your mind. Any thoughts on there? How is it the same? How is it different?
I think the first piece from when you look at a WS implementation, the first fundamental difference, I believe, is not being constrained to what you do today, but, incorporating what you think you're likely to do. With WMS, implementations, a lot of times, granted, you do plan a little bit up ahead, so I don't want to take that away. But, when you look at WMS implementations, you're looking at, what am I, what do I do today? What people, resources do I have? How do I do receiving? How do I put away? How many doctors? Blah, blah, blah. So you do all that facility design, all of that stuff, and WMS has a structured behavior for how you set that up. But when you do WES, I think you fundamentally are thinking about not one process, but you're thinking of collaboration. You're thinking of cross pollination of influences from all different process areas. So the requirements, the design process is fundamentally different. Today with WMS, you might have a conversation with receiving functional areas experts, or you can have picking experts or inventory control experts. But when you do WES, replenishment, hot orders, cross docking, picking, packing, shipping, all those have to be accounted for and can be incorporated to really get the benefit out of a WES. So I suspect WES implementations require much more broader thinking, both in terms of requirements and design, than typical WMS would do.
Very good. So I had another question come in, said something along the lines of, I'm surprised you didn't mention IoT, Internet of Things, in the smart warehouse discussion. We actually did have some materials on that that we just decided in the interest of time we were going to cut it out. I'll say real quick, certainly this notion of understanding where we use kind of a beacon system, but understanding where all human associates as well as any mobile equipment resources you have, and being able to do some optimization around that certainly has a role to play here. There's a number of analytics you can do with the IoT in terms of are the workers really following the most efficient travel path? Are they staying within their geofencing, if you will, zone within the warehouse, things along those lines. And we've always talked in the history of WMS around kind of assigning work based on permission, priority, and proximity. But that proximity has always been somewhat of a guess where we think they are, based on maybe the last thing they scanned or where we think they're headed or whatever. Obviously, with IoT, you can know precisely where that worker is, and hence just add some additional efficiency to that the 3 Ps of task assignment. So I just ran out of time for it, but certainly I think it has a role to play here. And then Dinesh, I'll throw this to you. In that list of questions we had that the WS is capable of answering, we kind of referenced the dynamic assignment of workers to different areas, maybe every hour or whatever that must be. Can you maybe just talk about that a little bit?
So of balancing or reassigning, is that the question?
Yeah, reassigning, I think, is the thrust of the question.
Yeah. No, I think it's effectively what it is boiling down to is looking at if you think of a most simplistic scenario, you had a certain throughput that you expected out of a case pick versus an each pick based on whether it's engineered standards, inferred standards, whatever, and you have a certain behavior that you expect, and you say this is what I'm going to plan for. The reality is on the floor at that point in time, it may be different, whether it's for resources not showing up, reduced capacity, or people performing at less than capacity, or people performing at greater than planned capacity. So any of those conditions. So based on the demand, then identifying what the constraint is, and of course the drivers are whatever your minimum requirements are, whether it's an SLA, whether the product has to ship out at a certain time, and so forth. Incorporating all that and identifying where and who is best equipped, not just whether moving from a case pick to an each pick or reassigning resources, but also incorporating the right resources. So if you have off a pool of resources, you have certain people who are been there longer as opposed to a temp labor, and so they are more efficient. You don't have to audit check if they are into an each pick area versus if a temp labor is there, then you probably need to audit check. Depending on how it is structured, WS, those can all be rules defined in WAS, and then WS will automatically balance and push or make sure those tasks are available to the right resources.
Okay, very good. Well, with that, I think we're going to wrap it up here. We have one more slide with some contact information. I'm having a little trouble advancing it again, but I think we're good. We'll send out an email to everybody that's going to have that Hot Topics report link. It'll have how to get a hold of Dinesh or myself with any follow-up questions you may have, et cetera, et cetera. So I want to thank everyone so much for joining us today. Obviously, there was a lot of interest in this in terms of the pre-registration and now attendance here for the day. So hopefully we hit some high notes for you here today. If there's something we didn't cover or you want to discuss in more detail, happy to do that. And I want to thank CSCMP for giving us the opportunity here to present this. We're in a new era here with WMS+WES. It's exciting after 20 years of kind of incremental gains. There are now some rather substantial gains, and we think it's going to be exciting for all of us in the business, so either as practitioners or as software providers. So thanks so much, everybody. Have a great day. Hope to see you on another broadcast here very soon. Thanks so much.
Yeah, likewise. Thank you, CSMP, and thank you, everybody, for tuning in, and hopefully it was worth your while. I appreciate it. Thank you.